Hello, my name is Paul Bevan from Siemens Digital Industry Software, and I'd like to take you through a new enhancement to molded part design in the December 2023 release of NX. Making smarter decisions in a timely fashion is key when designing better products with fewer iterations. And with that in mind, we've included draft angle prediction for molded part design in this new release of NX. This AI-enabled capability predicts the draft angle for your component based upon aspects of your design, such as design thickness, the draw direction, and the material that's been assigned. Let's take a look at this new capability in more detail. You can see in the graphics window we have a plastic component. It's a speaker housing, and we're going to take this into molded part design and use some of the tools that are included to verify the model to check that it's moldable. So I'm going to activate molded part design, and the first thing I'm going to check is the draw direction. And as you can see, the draw direction is coming away from the part, and I'm happy with that. Now I want to look at how moldable the part is. So I'm using moldability validation, and this is going to run a number of different checks and look for thin walls, thick walls, vertical walls, and undercut regions. And when I run the analysis tool, you can see I get a visual report with areas of concern that are tagged and color-coded, so I can easily look at them and find out what needs to happen. Here you can see some thin wall regions, some undercut regions here that might need a different type of tooling, and also some vertical walls. So these walls don't have any draft. So let's take a look at how we can fix some of these issues. So I'm going to start by hiding the validation results. And now I'm going to take a look at adding some draft to some of the vertical walls. So I select a stationary face, which is the top face of this feature here. And then we'll select some faces to draft. It sets the default at 10 degrees, but I can use the new recommend draft angle option, which gives me a number of different draft angles dependent on the material that I'm going to use. As you can see here, material currently has not been assigned, so I get the full list of materials along with their minimum draft angle. It's also given me information of what it's using to base the draft angle recommendations on, such as a larger draft angle may result in a part being easily removed, whereas a smaller draft angle might result in a smoother surface finish. So these recommended draft angles are intended to be a balance of these factors. So let's add a physical material to our component. We can do that from within inside of molded part design. I'm just going to assign ABS. It's a local material inside the part. I pick the geometry. That material is now applied. And let's go through the same process of creating that draft. So again, pick my stationary face. Then the faces I want to draft. Again, it shows that default 10 degree. But now when I show the recommended draft angle, you'll notice that the minimum is 2.1 based upon the material type. I apply that, and that particular draft angle has been added. So I'm going to continue to add draft, this time to the internal faces of this feature. So I pick my stationary face, then the faces to draft. And now when I select the recommend draft angle option, I get a slightly different minimum draft angle to apply. And this is not just based on the material, but also it looks at other geometric conditions such as the maximum depth along the draw direction. I'll continue to add further draft, this time to this area here. Again, when we look at the recommended draft angle, again it's slightly different because it's a slightly different geometric condition. Now when we go back to the moldability validation, you can see that it's out of date, so we're going to update it. It runs through the same checks, but now the issues that I were having with some of the vertical walls have disappeared because we've added draft to them. Now, in reality, I would continue to make modifications to the model to ensure that the component is fully moldable. But for this demonstration, I'm going to stop it right here and just recap what we've looked at. So we started with a plastic component. We took it into molded part design, and the first thing we looked at was the draw direction. We then used moldability validation to check the suitability of the design. And moldability validation performs a number of different checks, and it highlighted some areas of concern with respect to vertical walls, undercut regions, etc. We then concentrated on the vertical walls and used the draft command inside of molded part design to make some changes. Molded part design draft has some AI-enabled technology that allows it to recommend a draft angle for particular areas of the model based upon not only the material but also geometric conditions. And we use that to make some changes to the part itself. We then revalidated the design, and we saw that the areas that we changed had fallen into line and were no longer a concern. So that was a brief demonstration of the new AI-enabled draft angle prediction found in the December 2023 release of NX. I'd like to thank you for your time and attention.